So here we are with a beautiful question upon the limit, and to solve it we need to first check the form of the limit. So if we can see that x is tending to pi by 2, so if we put here, then the tan part would be 1, so 1 minus 1 is equal to 0. That will make the numerator 0, right? And if we see the denominator part, so this is fine, this would be 2, but if we put 1 x is equal to pi by 2 here, then this would become 0, right? So it is basically 0 by 0 form. So one way would be that we could do L'Hopital, differentiating the numerator and denominator. But the point is, you can see that here these are in the multiplication and these are trigonometric functions, so that would make differentiation a bit cumbersome also. It would go multiple steps actually. So let's search for some other way. Let's see if we can use some trigonometric functions or not. So if you see here, what is this? Just observe this. This is basically nothing but tan pi by 4 minus x by 2, right? Okay, so we can write this whole limit thing like this now. And this part I am writing right now it as 1 minus cos of pi by 2 minus x. Why I am writing it as it like this, you will see in a minute. Okay, fine. So what we can do now is, let's take this 2 that is here, we will take it out. Okay, so let's do that. So this would be like 8 and pi by 2 minus x the whole cube. Okay, now so if x is tending to pi by 2, we can essentially mean that pi by 2 minus x would be tending to 0, right? So let's substitute it as like pi by 2 minus x be h. Okay, let it be like this. Then this is basically we are changing the phase, or we can say that we are changing the variable right now. So limit h now would be tending to 0, right? So what we will write this, if you observe this, this is nothing but h by 2, simply h by 2, right? Great. And the denominator part, if we see, it is simply h cube, right? What about this thing now? Okay, so this is basically 1 minus cos of h, right? So now we know one thing. What do we know? We know that if limit, let's say y tending to 0, and if it is tan y by y, then that would be 1, right? And we also know that in the same thing, let's say limit y tending to 0, tan y, tan y I've already written, sin y by y, that's also 1, right? So can we make use of them? One important thing in the limit is, like, if the y would have been say y by 2, then denominator also demands to be y by 2 only, then this would be valid, right? So if we see in our main problem, let's come here. So limit h tending to 0, and basically I am trying to make the faces of the limit same. So let's say this is like this. I will simply multiply 2 here, and then I just told you that sin y by y tends to 1 if y tends to 0, right? Can we somehow manipulate this? Can we manipulate it or not? So I know one thing. What do we know? Basically in the maths, what we have to do, we have to see where we have to go, and we have to know what the tools that we have, right? So one tool that we have is 1 minus cos square x is equal to sine square x, right? Is it not so? Right. We will make use of. How can we make use? Okay, can we make somehow 1 minus cos square h? Yes, we can make it. How? Simply we will multiply denominator and numerator with this. Okay, simple. What will this become? This will become 1 minus cos square h, right? What is this? This is nothing but sine square h, right? So let's come back, and we have almost solved our problem, because this would be 1, right? So we can simply write 1 by 16 into, I was missing the denominator part, the h square, right? These are the mistakes, sometimes it happens. So no worries, here it is sine square h, and here it is h square, and here 1 plus cos h is also there. So if we see this part, this would simply evaluate to 1. And if we see this part, the cos 0 is equal to 1, right? So this would evaluate to 2, right? So this would become then 1 by 32. Simple. Because this will go to 2. Okay? That's for all for today.